Hi viewers, welcome to my short video on sharing in a ratio, and in particular sharing a ratio when the difference is known. I've already filmed the video on sharing in a ratio where the part is known, which for me is where we should start with exploring sharing ratio with pupils. So if you haven't watched that video, you may want to go and watch that first, because that's the one for me where we should start, and I make my reasons for that clear in the video. Uh, Next, we're looking at sharing in a ratio where the difference is known. And for me, it doesn't actually matter whether we look at when difference is known or when total is known, but I would definitely start with sharing where a part is known. And so here we've got a problem. Tom and Hannah share some money in the ratio 3-5. Tom gets £24 less than Hannah. Work out how much they share. And if we're going to look at this ratio 3-5, very typical representation for looking at a ratio like this is to use a bar model. And we can see I've got my Cuisenaire rods out here. And Cuisenaire rods, for me, one of the big uses, one of the big advantages of Cuisenaire rods is they can be used as a physical, concrete manifestation of the bar model. So if you're wanting to explore bar modeling with pupils and you're wanting to use a concrete manipulative to support that, then for me, Cuisenaire rods is definitely the way to go. So if I was working on this with students, with kids in my class, I'd be saying, right, Tom and Hannah share some money in the ratio 3-5. Let's just stop there. Let's look at that. So show me 3 and show me 5. And what I'd expect kids to do is to sort of get out these two rods. This is can be seen as the 3 rod, the 5 rod. It's not the only rods we could use to represent the relationship between 3 and 5 there, but they are the smaller rods and the most obvious rods in this case. So we've got this ratio 3-5, and we go through the usual stuff that I would go through. Okay, so which one of these represents Tom's share? And obviously Tom is the green because he's the 3. Which represents Hannah's share? Hannah's the 5, so she's the yellow rod. And then, as I did before in my previous video, sharing when a part is known, we'd start with just tell me about the relationship with these rods. Tell me about these rods. And what I'm looking for here is for kids to be telling me, like, this is 5/3 of this one, this is 3/5 of that one. And sort of those multiplicative relationships between the rods, which, as I explained before, and I will explain again, are for me the crucial relationship that exists within ratio. So once we've got the 3 and 5, and we've sort of explored that a little bit, we'll have a look at the next bit. Tom gets £24 less than Hannah, and that sentence, the first time kids come across that and come across problems of this type, that sentence needs a bit of unpacking. And what we're aiming to get to here, we'll have a conversation, some discussion, some questions, is the idea that this is talking about the difference between Tom and Hannah's share. And whether it's phrased as Tom gets £24 less than Hannah, or Hannah gets £24 more than Tom, or the difference between their amounts of money is £24, it doesn't really matter. We're focusing here on the difference between Tom and Hannah's share. So we can look back at our bar model, our Cuisenaire rods here, and say, okay, well, where's the difference? Where does it talk about? Where do we see the difference between these two parts of the ratio? And, it doesn't take long for kids to say that the difference is here, that too. And we can even bring in the red rod here, which is worth 2 in this scenario, and see that fills the gap. It is the difference between those two. And this creates what primary school teachers in particular would be very, very aware of, which is a part-whole model. We can see here that, 3 plus 2 is 5, that 5 minus 3 is 2, the difference between 5 and 3 is 2, or 5 minus 2 is 3, the difference between 5 and 2 is 3. And so whether we're actually using the red rod here, or we're using a brace in our bar model for this difference, makes very little difference to the scenario. The key thing here is that this 2, this space of 2, or this rod of 2, is that £24. So this is a representation of that 24. And so now we're going to be saying, okay, well, if this 2 is worth 24, if this 2 represents that 24, tell me about the other rods. And similar to before, in my previous video, when sharing when we know a part, I don't really, in most circumstances, want kids to be telling me, okay, well, if this is worth 24, then a single square is worth 12, or the white rod is worth 12. And so this will be 12, 24, 36, and this will be 12, 24, 36, 48, 60. what I want kids to be doing is a couple of things, and what I want to be highlighting if kids don't do it is a couple of things. That if this is 2 and represents 24, then the value of this rod is 12 times bigger than its length. And so the value of this rod is going to be 12 times bigger than its length, and the value of this rod is going to be 12 times bigger than its length. And the reason for that, and for the other relationship, which I'll highlight in a minute, is that those multiplicative relationships between the rods and between the rods and the values, as I said, are sort of the really important relationships for working with all sorts of ratio and proportion type scenarios. The unitary method, what is one worth, has its place and is very good when we're looking at things like unit pricing, rate of change, things like that. And it can be tied into what we're going to do later on, as we'll see. But they're the key sort of relationships that exist within these ratio and other proportional problems. And so they're the relationships I want to highlight. The other key relationship here, similar, and this is why we did that bit at the beginning, this is 5/3 of that, this is 3/5 of that, is I also want them to be talking about, well, this is going to be 3/2 of that. So if I multiply 24 by 3/2, and this is 5/2 of that. So if I multiply 24 by 5/2, I'll get Tom and Hannah's share. And then when it comes to looking at that in the abstract, or at least the partial abstract, I'm going to use one of my favorite devices for working with ratio. I'm going to use a ratio table. And so we're going to set my ratio table up here with Tom and Hannah having money in the ratio 3/5. And that's just a representation of this bar model now. But then that second sentence we said focused on the difference. So what I'm going to do here is I'm going to add a column to my ratio table which focuses on the difference between these two values. And as we've seen here, the difference, whether it's the gap or whether it's the rod, the difference here is 2. And it's that 2 that represents the £24. And when we've got it set up like this, we can see all of those wonderful relationships that I highlighted before. We can see that scalar relationship, as we typically call it, that scalar multiplier, that the value of the rod is 12 times bigger than its length, or the value of the bar is 12 times bigger than its length. And so the values of these bars are going to be 12 times bigger than their length. But we can also see that relationship, that this Hannah's share in this case is 5/2, or 2.5 if you want to turn into a mixed number, but 5/2 the size of the difference. And similarly, that Tom's share, Tom's part, is 3/2 the size of the difference, or 1.5 times bigger than the difference. And again, these functional multipliers, as they're normally called, although you can call them exchange rates or even conversion factors in appropriate circumstances, these functional multipliers are really the key relationship that exists here, because it's the relationship that doesn't change. Yeah, it doesn't really matter here if Tom gets £24 less than Hannah, or if Tom gets £36 less than Hannah, or if Tom gets £1,005,000 less than Hannah. Hannah's share will always be 5.5 times that difference. Tom's share will always be 3.5 times that difference. And when we're wanting to move on with ratio and proportion, getting towards that y equals kx relationship, representing this sort of problem algebraically, it's those relationships that are going to be that K that are going to tie that together. So focusing on them now, for me, is really important. And even at this stage, I want to be bringing those in, as well as, like I say, to reinforce that idea that any number can be turned into any other number by multiplication. And it may not be a whole number multiplication, but it can happen. And so in this case, it doesn't really matter which relation. And there's, in all cases, it doesn't really matter whether we use the scalar relationship, whether we use the functional multipliers here. We're going to get that Hannah has £60, and we could have got that just from the bar model, but I would be showing these two alongside each other. And we're going to get that Tom has £36. And so when we're answering the question, how much they share, well, in total here, we can see they've got £96 that's been shared between them. Now, that, as similar to what I did in my previous video, that actually wouldn't be the first question that I would ask pupils. The first question that I would look at with pupils, that I'd model and explain and explore with pupils. The first question would probably be work out how much Tom and Hannah each get. The reason I've used this problem as my example with you is because actually what I can see here is that I don't really care about what Tom and Hannah get at all. I'm being given information about the difference between their shares, and what I'm interested in working out is the total. And so what I go on to look at with pupils in this case, and this is why I wouldn't do this first, because I'd want to have this table set up first, and this table very naturally comes out with how much each of them gets. But what I could actually do here is simply focus on the relationship between the difference and the total. And we've seen here that the difference between them is 2. And we can also see that the total of the two parts is this rod here, which is 8. Okay. And we can see both of those in this picture. We can see the difference is 2 because that's Tom's share. This is also Tom's share. And that's the difference between Tom's share and Hannah's share. And we can see that total of 8 across the two shares. And so actually here, if I just look at the difference compared to the total, the difference of 2 and the total of 8, as we had before, that difference is £24. And now I'm interested in, well, what's the total amount of money they have? And the T here stands for total, not for Tom's share, just to be clear. And we can see we've got that same scalar relationship, the multiplication by 12. And we've got another functional relationship now, this time between the difference and the total, in that the total is 4 times bigger than the difference. And again, I want to focus on that one. I want to highlight that one with kids because that's the one that no matter how much that difference is actually worth in terms of money, as long as this ratio 3:5 exists, the difference between the parts will always be 2. The total of the parts will always be 8. And so this total will always be 4 times bigger than this difference. And whether this number is 24 or 36 or 1,000,005 or whatever you want to call it, that relationship will always hold true. And so, again, doesn't really matter which relationship we use, whether we multiply that one by 12. And of course, there's a lovely conversation to be had here about why 8 times 12 and 24 times 4 are going to give us the same result. Regardless of being able to work out the result, we can have a conversation about why that multiplication and that multiplication are going to give the same answer. But we're going to get now directly that £96, which we got before by looking at Tom and Hannah's share separately. So that is my short video on exploring sharing with a ratio when the difference is known. As always, I'd like to say a massive thank you to Johnny Hall and his website here, mathspot.com, which I use the virtual manipulatives on to create all of these videos. And you can see here that Johnny's got a wealth of different virtual manipulatives on his website. But it's not just virtual manipulatives. And if you're a maths teacher that hasn't checked out Johnny's website before now, then I would heartily recommend that you come and have a look at mathspot.com. It's got all the virtual manipulatives, but it's also got question generators, it's got worksheet generators, it's got starter tasks, it's got lots and lots of things for maths teachers to make maths teachers' lives easier. And if you are interested in manipulative representation structure, then I would also suggest checking out my own website, visiblemaths.co.uk. And in particular, on there, you'll find details of my book, or my first book, because there are a few of them now, but my first book, Visible Maths, which is entirely about using representation manipulative structure to enhance maths teaching and to support kids in making sense of mathematical ideas. So that's the end of my video. I hope you found that useful, and thank you very much for your attention today.